we know that every rational number can be expressed as a decimal number. For example, 1 by 2 can be expressed as 0.5. The decimal number obtained will be of two forms. Limited number of digits after decimal point, which is called as terminating decimal. There is no limit for number of digits after decimal point, that is, a group of digits repeats again and again, which is called as non-terminating repeating decimal. Let's consider some of the examples. 3 by 4. Here, the decimal expansion of rational number 3 by 4 equals 0.75, has a limited number of digits after decimal point. Hence, we can say that 3 by 4 is a terminating decimal. Let's consider one more example. 257 by 16. Here, the decimal expansion of rational number 257 by 16 equals 16.0625, has a limited number of digits after decimal point. Hence, we can say that 257 by 16 is a terminating decimal. Let's consider one more example. 2 by 9. Here the decimal expansion of rational number 2 by 9 equals 0.222 and so on. Here the digit 2 is repeating again and again. Hence we can say that 2 by 9 is a non-terminating decimal. A non-terminating decimal in which a digit or group of digits is repeated continually is known as recurring or repeating decimal. A non-terminating decimal, the repeating digit or group of repeating digits is called its period. For example, in 2 by 9 equals 0.222222222, in which 2 is the period. Consider a rational number, say p by q, where q is not equal to 0, and explore exactly when the decimal expansion of p by q is terminating, and when it is non-terminating repeating, or recurring. Let us consider the following rational numbers. 0.27 is equal to 27 by 100, which is equal to 27 by 10 square, which is equal to 27 by 2 square into 5 square. Let's consider the one more rational number. 0.104 is equal to 104 by 1000, which is equal to 104 by 10 cube, which is equal to 13 into 2 cube, is divided by 2 cube into 5 cube. As one would expect, they can all be expressed as rational numbers, whose denominators are powers of 10. Let us try and cancel the common factors between the numerator and denominator, and see what we get. 0.27 equals 27 by 100 equals 27 by 10 square equals 27 by 2 square into 5 square. 0.104 equals 104 by 1000 equals 104 is divided by 10 cube equals 13 into 2 cube is divided by 2 cube into 5 cube equals 13 is divided by 5 cube. Thus, we have converted a real number, whose decimal expansion terminates, into a rational number of the form p by q, where p and q are co-prime, and the prime factorization of the denominator, that is, q, has only powers of 2, or powers of 5, or both. We should expect the denominator to look like this, since powers of 10 can only have powers of 2 and 5 as factors. From the above examples you can see that any real number which has a decimal expansion that terminates can be expressed as a rational number whose denominator is a power of 10. Also the only prime factors of 10 are 2 and 5. So, cancelling out the common factors between the numerator and the denominator, we find that this real number is a rational number of the form p by q, where the prime factorization of q is of the form 2 to the power of n into 5 to the power of m, and n, m are some non-negative integers.